Right now, I'm going to just solder off a switch from a circuit that I don't use. Circuit board I don't use. It took me a while to solder this off because I didn't have a piece to screw off some of the things on the front of the metal sheet that you see. So I ended up just twisting the switch a lot and pushing it a lot and bending the metal piece a lot, and it worked. Luckily, I just took the button off of the circuit board and it was a pain in the ass. But now I'm going to put the wires onto the button so that I could connect it to the breadboard and show you guys how buttons work. It took me so goddamn long to figure out why the switch was not connected to the wire. It was like, what the fuck? It just needs to be vertical. Obviously, it's common sense. So after that fucking shit, it became really easy to put the other wires on, but it took me like 20 minutes to put that first wire on. It was insane. I don't know why I wasn't thinking right. I was like, oh, this is a good idea. It stuck a little bit, so why not try it again? Anyway, this is a single pole double throw switch, which that means it's like an on and off switch. The left and right wire are the wires that are going to be determining what is on and off. The middle wire is what you plug your device in. So if the switch is connected to the wire that is connected to the negative terminal of the battery, then flow is able to go through because then it's a complete circuit. Or if the switch is on the other side where it's connected to the ground, then there's no circuit available. So therefore it's going to be off. That's how a switch works in this sense. There's all kinds of switches. You got dip switches, pole switches, potentiometer switches, all types of fucking switches. And they're all really cheap. So now we're almost done. This was overall pretty easy, but overall really cheap. It was like the cheapest thing you can fucking do. Like, I spent $10 on the fucking solder, and I fucking took a circuit board from the attic that was up there for like 10 years from a fucking some dumbass video playing thing, and fucking here you are. The shit people can do, but they just make excuses like, oh, I don't have the money. Try something. Please. Here you go. Done. The first thing I want you to understand about switches is that they are classified depending on pulls and throws. Right here we have a single pull, single throw switch. The pull is represented as when you move the switch, one connection, how many different little interconnections are moving as you move that. And then the throw is classified as what you're moving to. Is there several slots that you can move to, or is there just one or two? Right here we have a single pull double throw. As you can see, we have two different slots. That's why it's a double throw. A single pull would have two different connections that move as you move one slot. Now, that is just a classification for switches. This is like an on and off switch because you can move one over and then it's connected. And then if you move it over here, it's connected to this one. So one's off and one's on. You could have one connected to ground and then another one connected to power source. And that's why single pull double throw is useful. And that is what we are using. Now I'm going to show you guys how it works on a breadboard. Here's the schematic for the circuit we're going to build. We got a single pull double throw switch, 6-volt battery, 270 ohm resistor, and an LED. Right here is the switch, and as you can see, this wire right here is connected to the negative terminal, so when I plug in the battery, the current's going to go through this wire. And as you can see, the switch is on the off position because it's not connected to this wire, so no current could flow through it. It's connected to this one at the moment, which is connected to nothing. So I'm going to plug in the circuit and show you guys what I mean. Right here, we're going to plug in from the negative terminal because that's what's plugged in to that wire. And then let's plug in the cathode of this LED. It's a resistor, again, because it's connected to the negative terminal of the battery. And then we're going to plug in a wire to the anode of this LED. And then we're going to plug it into the positive power rail, and then I'm going to plug in the wires for power and As you can see, it's not going to turn on because the power is not going through. And now I'm going to switch it over so current can flow through. As you can see, it works. That's how a switch works in a breadboard or in any logical situation. You can classify it with pulls and throws. Thank you guys for watching. See you guys next time. Peace.